Hi, I'm Rob Futrick, Azure's PM lead for our HPC software and services team, and I'm here at Azure HPC and AI Day to talk to you about that platform, a little bit about kind of our mission and how we approach what we do. And then I'll go through the actual platform itself, and then I'll talk a little bit about where we're headed, at least in the near term. And the first thing you're going to hear from me, and probably from anyone today, is about how at Microsoft we are a supercomputing company. And what we mean by that is we really try to produce a differentiated solution. We want to give you the best HPC and AI cloud experience, or honestly, just the base HPC and AI experience. And we take a genuine HPC approach. And we're an HPC team. We are HPC people that do cloud, not the other way around. And I think that really shows in the platform that we produce, the benchmarks that we run, the team we've built. Kind of you name it. And we understand that HPC is a cutting edge thing. It's always pushing the limits, almost by definition. And so we need to be leading in time to market with the appropriate technologies, or we will not be able to help you, kind of push the boundaries. In order to do that, we have to be price performant. We have to be competitive. We have to meet your technological needs, and that means we're deploying purpose-built infrastructure. That's the only way we're going to be able to reach the performance and the price performance that you need. It's kind of similar to how you want to haul a lot of stuff. You get maybe a big Ford truck, but if you want to drive 200 miles an hour, maybe you get a Tesla or Lamborghini or something like that. And we also understand that this is not a transactional relationship. This is a partnership. This is a journey together. We are not in this alone. So we're not just trying to sell you cloud. We are looking to help evolve what HPC is, what AI is, and how they can really kind of drive things forward. Now, out there, other people have VMs, they have infrastructure, they have storage, networking, and tie it all together. But Azure really is different. We're the only public cloud provider that's really offering the full range of HPC capabilities. And how you access that is actually kind of gets to the heart of the software and services team's mission. So we're cloud built for HPC. I think that shows up in the purpose-built infrastructure, CPUs, GPUs, etc. The networking that allows all of it to communicate together, as well as allows you to talk to Azure, and the storage that kind of drives the speeds and feeds and whatnot. Now, where our team comes in is really in that workload orchestration side. It's the end-to-end workflow agility. It's the tools that make it so that you can tie all of that purpose-built infrastructure together in a way that is familiar to you and kind of fits with your existing processes or where you want them to go. And then again, getting back to the idea this isn't transactional, this is a relationship. The end-to-end experience is what matters when trying to tie it all together. We are on a mission to provide a world-class end-to-end experience, and that means from the moment you talk to Azure to the moment you get your results back, and then so on and so forth. We want to drive delight at every aspect of that experience. And that's the heart of what we're trying to do. HPC and AI are hard. That is almost a tautology. If people doing these problems, if people working in these areas could be doing more, they would be doing more already. They're always constrained by something. It could be budget, it could be access to infrastructure, whether it's we don't have enough cores, or maybe it's a new kind of infrastructure, a GPU or other accelerator or storage technology. It could be access to data, it could be technical complexity, you name it. But in some way, they're constrained. They can't do more than what they're already doing. And this kind of reminds me of one of my favorite quotes. It's from Brian Kernighan, and it's he's one of the creators of the C programming language, which was the first language that I had much experience with. And it's debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. And so, that really kind of focuses my my mission here. To succeed, cloud must unlock agility and innovation and transformation and all that kind of stuff. But we can't add cost, especially unmanageable complexity and other friction. If you're already operating at the limits of your abilities in some dimension, and we say, come to cloud, there's dynamic infrastructure, there's amazing transformative services. By the way, it's harder, or it pushes on that boundary. Well, that's almost a non-starter. So we want to simplify cloud, we want to simplify HPC, we want to simplify AI, we want to simplify that journey. And this shows up in the resource stack. We have the optimized compute. That's how we built the purpose-built infrastructure, the H series, the N series, and other offerings. It's the storage that we tie into it, whether it's HPC cache or Azure NetApp files, or even just blobs and disks, in Cluster Store. The networking that allows you to talk to Azure, as well as all these cool technologies inside of Azure. And then my team's offerings, Azure Batch, Azure CycleCloud, Microsoft HPC Pack. These are the tools that allow you to easily tie all those other technologies together, to deploy them, to utilize them, to manage them, etc. But you'll notice that we also view ourselves as kind of a bridge to Azure's transformative services. That could be Azure ML, it could be Synapse, Quantum, Databricks, things that aren't even yet conceived. But the goal here is as we evolve HPC, as we evolve how we are doing things, we need to make it easy to incorporate those new technologies, whether it's for engineering reasons or even just for business process reasons. But more than the technology, more than the specific offerings, our philosophy here is driven by that same simplification and that same kind of meeting you where you need. So we have our standard tools and technologies. You're running existing software. You're running job schedulers. You're running workflow managers. Maybe you're looking at containerizing your workloads, or you're incorporating AI, or even running distributed training, and you want to access the toolkits that you need. Either way, we want to meet you where you are so that you can continue doing what you're doing without the friction of a re-architecture or redeployment. Not only in the powerful infrastructure are we providing the purpose-built technology and the breadth of offerings, but we understand that hybrid is key to enabling you to maximize these investments that you've already made and are looking to continue to make. We understand that given the highly optimized nature of our workloads, that hybrid is part of that. And so both hybrid and cloud native are key to our approach. And because these workloads are so complex and so dynamic, you need full clarity and control. You need to have monitoring. You need to have end-to-end traceability and auditability and understandability. You need to know who is running what, where, at what cost. And so cost reporting and cost controls are another key part of being confident and able to run in cloud and drive these workloads forward. And governance almost goes without saying. We have to integrate that from the ground up. And then back to the end-to-end experience. Again, it's not just the technology that we offer, it's understanding we need to provide a world-class HPC and AI support experience. As we release new offerings, as we integrate new tools, as there are new partnerships and new scenarios, we have to offer training, we have to offer documentation, we have to help the entire community kind of upskill, not just in the Azure specific technologies, but in kind of the new ways that you can do things. And that really can be helped along with a lot of community engagement. We're not in this alone. Not a single customer of ours or a single partner of ours. It is a community, and no single one of us is as strong as all of us, and we need to drive that community in order to continue kind of pushing forward in our mission. And that includes ecosystem development. So we need to make it easy for our partners to engage with us, to engage with our platform, and drive it forward. So back to the specifics of the platform. I told you a little bit about where or why we do what we do, the importance of the mission, and how we view ourselves pushing this forward. And here's a little bit about what our current platform is. We have a native offering in Azure Batch, and that is a cloud native job scheduler. HPC as a service model. All the resources are cloud-based. It's very simple, very scalable. Get to that in a second. Complementary to that is Azure CycleCloud. Now, Azure CycleCloud itself is not a scheduler. It's really more of an administration tool and a dynamic resource allocator that is a way of using industry standard HPC job schedulers. And unlike Batch, it actually supports both hybrid and cloud native. Now, Batch, so we've kind of talked about that dynamic infrastructure is the first major challenge. You come to cloud and there's nothing there. That's your chance. Is to define the infrastructure and then to spin it up. And so in Batch, that dynamic resource allocation, that orchestration, that's handled by Batch pools. It's simple, it's extremely scalable, it's fully managed. It's and efficiently auto-scales your infrastructure up and down. and it allows you to kind of automatically optimize both your infrastructure and your cost. And complementary to that is the Azure Batch Scheduler. Now that's the job scheduling part of Azure Batch. As you would have guessed, it's also extremely scalable. It's full-featured, and it's a cloud-native job scheduler. Kind of, everybody here I think understands what a job scheduler is. You can run any application unchanged. You can run containers. You can run Windows, Linux, custom images, and more. Put together, it's a simple and powerful service. It is the easiest way to run batch jobs at scale in Azure, and I would argue anywhere. It will detect and retry failed tasks. You can do task dependencies and prep and cleanup tasks, etc. It's a very flexible system. As I mentioned, you can do Windows or Linux. You could run custom images. You can even use things like spot VMs where appropriate for your workloads in order to reduce your bill and maybe see a more efficient use of the cloud. It does have optimized auto scaling, and that's really driven by the job's requirements, as you would have guessed. And one thing that's worth calling out in addition is that it is a developer platform. And so Batch is really meant as a way for people to cloud enable their workflows and their software and kind of create their own SaaS or PaaS offerings. As a result, as you would guess, it does support all the common languages and frameworks. And things like Ansys Cloud are actually built on top of Batch. But beyond job schedules themselves, Batch serves as an integration point for workflow managers. And so we have done a lot of work to integrate with those tools. And the great thing about this is this means that you can maintain the workflow or pipeline portability that you've already invested in. So that gives you a chance to leverage, all that infrastructure, all that kind of process you've built up on-prem. You can now leverage that in Azure as well. That means you can run workflow processes as batch tasks. You can use Azure Blob Storage containers as input and output locations, and so on and so on. And a lot of these tools are open source, and so the integrations are kind of live on GitHub and everywhere else. And there's just a fun little screenshot of one of the first times a while back that I saw Nextflow running in Azure. So Batch, again, cloud-native job scheduler, HPC as a service model. Give us your jobs, handle dynamic resource allocation for you, up and down, give them back. Simple, scalable, efficient. But that requires you using a native job scheduler. And so if you're already running Slurm, you're already running PBS, you already have existing systems, then Azure CycleCloud is more your option. It is a tool for creating, deploying, operating, and optimizing HPC clusters in Azure. It's the fastest way to get started. You can deploy a complete cluster in minutes. It's really, we often actually recommend people essentially conceptually lift and shift their environments to Azure. It's not necessarily the most optimal way of running in Azure, but it's by far the easiest. And it gives your users a way of validating their workflows running in Azure because they're using the same system that they're already used to. And so you can Azure enable your workloads with no changes. It does support industry standard job schedulers, just like Batch in terms of that dynamic allocation. It's essentially what adds dynamic allocation, dynamic orchestration to third-party and in-house schedulers. And it's a traditional scaling methodology. It is one thing that's interesting to note is it is infrastructure as code approach. So you do have kind of a configuration template, a CycleCloud template for your clusters that you can then templatize, you can standardize, and then you can version them. And really kind of ensure auditability and repeatability and whatnot. CycleCloud includes built-in cost reporting and controls. So there are tools to manage and control your costs. And then you can link your usage to your spend. And it has all kinds of authorization and governance features included as well. So use all the infrastructure. You have existing investments, or you're planning on making future investments in on-prem. You can take your Slurm cluster, your PBS cluster, your LSF cluster, and you can burst them into Azure. And the nice thing is you can actually control when and how. So that might just be simple overflow. You've kind of provisioned for your steady state use cases, and now you need to burst into Azure. It could be to take advantage of a new technology, maybe a new GPU family, a new accelerator, a new type of CPU or storage. But now you have that flexibility of kind of continuing to drive the investments you've already made while maybe trying out new ones. Or it could even just be for regulatory purposes or other reasons. And as you might have guessed, the goal here is really to provide a first-class experience across any of the job schedulers you want. It could be the native batch scheduler, or it could be a third-party scheduler, or it could be an in-house scheduler. So we've talked a bunch about CycleCloud's auto-scaling, Batch's auto-scaling, but two things to call out. One is that they support both high throughput and tightly coupled jobs. So, it's the scaling methodology and approach for those are, as you would imagine, quite different. One is really more of just an aggregate volume, and the other is really more of a Tetris problem, if you will. And CycleCloud in particular has libraries where you can Azure enable in-house schedulers. We've had quite a few customers who essentially have added dynamic orchestration to their existing systems, and that's how they brought them to Azure. And as we touched on just a second ago, multi-dimensional orchestration is really something that can help unlock additional power. And it's just a fancy way of saying scaling beyond cores. So it could be memory as the constrained resource. It could be software licenses. It could be access to data or data I/O. It could be locality. It could be budget. There are so many more dimensions on which you can optimize your use of infrastructure once you have the ability to dynamically take it up and down and move it around. And getting back to the kind of simplifying HPC, as you'd expect, we strive for a simple and kind of expected interface. So all the standard ways of using these schedulers, that's what we want you to be able to use too, whether it's complexes or queues or however they are specifically configured, that should work in Azure. And we continuously update our integrations and supports, and we work with our partners to update their integration and support of the schedulers with CycleCloud. And sometimes that even results in a native integration. IBM's LSF actually ships with a resource connector based on CycleCloud built right into the software that you get from IBM. So a few callouts for Slurm. It's one of the more particularly popular schedulers. We do support the latest version with CycleCloud. It does support topology of MPI jobs that require InfiniBand. Now, one convenience that's really nice is that VMs with GPUs are automatically configured with the right settings. And you can leverage Slurm's built-in job accounting with CycleCloud's cost controls. And that's actually an area we're going to be building on significantly in the future. And you can also support slurm.conf settings right in the CycleCloud UI. So you can see a very tight integration there that we're hoping to continue driving in the future. For PBS, one thing to call here is PBS support is both commercial and open source versions. And as with Slurm, it supports the MPI job topology for jobs that require InfiniBand. And as I mentioned, it does do that kind of multi-dimensional orchestration for PBS clusters. Now, one thing that's different, Slurm actually does demand calculation itself. It figures out internally what infrastructure it needs, and then it requests it from CycleCloud. Whereas with PBS, actually, CycleCloud examines the PBS and determines what infrastructure it thinks PBS needs, which can lead to some optimizations and some kind of tighter orchestration behavior. And you can get some insights into that using the AZ PBS command line interface. So what have we been doing across our platform in 2021 and kind of so far in 2022, given that we're a few months in? Well, the big one is for the batch service is that we've reversed the node communication. So it used to be that the batch service talked to the compute nodes, and now the compute nodes actually talk back to the service. And that's kind of a deceptively complex change, but it really improves stability, it improves scalability, and it really simplifies the configuration of batch itself. You no longer have to open up ports on the compute nodes to allow the service to access them. The compute nodes do not need certain types of storage access anymore, and we no longer have to use self-signed certificates to encrypt traffic. Overall, just a better experience, and also the foundation on which we'll be building kind of additional security and other features. In batch pools, we added support for spot VMs. We added quite a few other features here. We added faster detection and recovery of unusable nodes for kind of an overall better error handling experience. We now have user-assigned managed identities, and they can be associated with batch pools. That allows those identities then be used to access other resources, virtual machine extensions, and kind of so on there. For availability zone support of note is that's in regions where batches deployed that themselves support availability zones, which is most of the private regions, but just in case you're running somewhere a little different. In Azure Batch Scheduler itself, we have that the tasks can specify the number of node slots they require. And so this really allows different ways of kind of manually controlling the kind of allocation across a pool of resources to different applications and different purposes. And we've made a bunch of improvements to error messages for unusable pull nodes. And that gets back to the end-to-end traceability and kind of understandability of what's going on in your environment. And to that end, we've also added an auto scale log event for pools. Now in CycleCloud, we recently released 8.2, and that includes new PBS autoscale project, a new cluster cost API, which you should definitely check out, disk encryption with customer managed keys in certain conditions, as well as self-healing for provisioning failures. And that will really help with with a smoother and more kind of automated cluster scale up, and maybe in kind of more constrained situations. As well as force delete support. And we haven't talked much about HPC Pack. HPC Pack's actually a traditional HPC scheduler as well. It's been around for quite a long time. It's quite a mature product. But recently we've upgraded it to integrate with CycleCloud 8 for the Azure Burst. So this is for people using HPC Pack to either burst an HPC Pack cluster into Azure or to just run a cloud native HPC Pack cluster. But using CycleCloud, you can now use spot VMs in HPC Pack as well as actually terminate delete for scale down. But these are only a fraction of what's actually been done. I was just trying to call out some highlights, give an idea of the breadth of changes we've made, and you can get a lot more of these updates available online. They're in the Azure updates, the URLs right there, and those are kind of snapshots. The CycleCloud documentation also includes copies of the release notes, and so a lot more detail there, especially for any, if you were curious about any of the specific items that I've called out. So, as part of the end-to-end experience, we've talked about this HPC team, but to get into some details, we have an HPC and AI support team, and they provide worldwide 24/7 support. And this is a team staffed by genuine HPC experts. They are on a mission to work with you to solve your needs. And these are people that have run clusters, run workloads, and done these things. They understand the challenges that you're facing. But on the flip side, they understand how kind of Azure is put together and how these technologies come together, and they are there to help you resolve your issues. And that's a screenshot of the Azure portal. You can see kind of how you get to the HPC team. It's actually the service type. And there's a couple other routes there as well. And to help drive kind of understanding and upskill everybody, as well as to drive engagement with the community, we've also produced quite a few modules in MS Learn. Now, MS Learn is free learning resources for Azure Online. And at the moment, if you go to aka.ms/HPC Learn, you'll see 13 free modules, more coming, covering compute and storage and advanced topics and beginner topics and you name it. And on kind of the intro end, you have things like Introduction to High Performance Computing and, how to create a cluster in Azure with Azure CycleCloud. Once you start getting a little more advanced, you have topics around actually running HPC applications or kind of selecting the right storage options or optimizing your use of ANF and others. So plenty of free content, looking to build on that in the future as well. So that's what our platform is and kind of where it's been. Coming soon, kind of in some ways more of the same. We're focusing on key features, security, and kind of core service improvements. In the batch service itself, there's going to be a lot of improvements to how we actually run the service. And the, why would you care? Well, you'll see a more stable, a more scalable, and a more kind of responsive service. And we're also going to drive some improvements to the UX through the portal and other areas of the kind of SDKs and whatnot. In batch pools, we're building on that node communication reversal. And now we previewed a no public IP feature last year. This is for having VMs that have no public IP. It's private access only. That feature won't go GA. We're actually essentially re-updating that feature to use the new communication model, and that's the version that we'll be releasing. And so we'll have updates a little bit later this year, but we're looking to preview that in the June-July timeframe. And because we release spot VMs, at some point we will be retiring low priority VMs as well, and there'll be quite a long, quite a multi-year planning over that, and we'll follow up again. On Azure Batch Scheduler, we're planning features around improved fair share and a whole bunch of kind of scheduling specific improvements. In Azure CycleCloud, we're going to continue doing core product improvements. That scheduler keep up and then kind of driving deeper integrations, as well as bug fixes and other minor kind of feature updates. And then driving those partnerships to either drive a tighter collaboration or tighter integration of CycleCloud with schedulers or other software, or the people who are building kind of their PaaS and SaaS offerings on top. On the support side, we are going to keep driving deeper partnerships so that you have a smooth support experience. If there are a combination of technologies, as there always are in your HPC environment, then we want to make sure that that team is set up, or that our partners are set up to really help you resolve your issues quickly and easily without a lot of being bounced around or people unfamiliar with other people's offerings. And then, as with the batch service itself and CycleCloud, ongoing portal and process improvements. And I already mentioned, but I'll mention again, that we plan to continue producing content for the community for training, education, and learning. So that all said, we actually want you. We want you to help us build the future of HPC and AI. So if you want to build the next generations of HPC and AI supercomputers, if you want to kind of create a truly transformative experience, if you want to help us drive that software platform and really simplify AI, HPC, and drive the evolution of both, and in doing so, if you want to unleash people who are working on some of humanity's most challenging problems and most pressing needs, then come join us. Come be a part of a fun, ambitious team. We're passionate about what we do. We're passionate about our mission, and we support each other, and we will support you in your growth and development. So go to careers.microsoft.com, search for Azure HPC. I think at the moment there's literally 79, but we have more coming. And this is across the spectrum: software devs, hardware devs, PMs, TPMs, biz devs, sales, you name it. Come be a part of our team. So next steps. You can go to azure.com. You can learn more about Azure. You can learn more about Azure solutions for your industry. And you can even engage a partner if you want to get started today. Also there is the HPC Learning at MS Learn that I mentioned, as well as a way to join our team. Thank you very much.